Ever tried, I don't know, like talking with someone who speaks a completely different language? It's like this massive wall between you.
Oh, yeah, totally.
And so think about this. We're trying to build AI that can understand all languages,
Oh, wow.
like every single one. There are over 7,000 out there.
Right.
Getting AI to really, truly get all the little things that make each language unique, that's like, I don't know, a Herculean task.
Yeah, it's a huge, huge challenge for AI, this whole language thing.
Yeah.
And one of the big things that researchers are really grappling with is this idea of global consistency in language models.
Okay, global consistency.
Yeah.
That sounds pretty important. It sounds foundational. Like, if we don't get this right,
Yeah,
then everything else is kind of messed up.
exactly.
So what does that actually mean in this context of AI understanding all these different languages?
So imagine like a map, right? A map in the AI's brain.
Mm-hmm.
We call this an embedding space.
Yeah.
And on this map, ideally, you want words and phrases that have similar meanings to be close together.
Okay.
But more importantly, the relationships between concepts, like, say, the connection between king and man,
Right.
should be similar to the connection between queen and woman, no matter where on that map those concepts are.
So like king and man could be over here.
Yes,
Queen and woman could be way over there.
exactly.
But the relationship, like the vector between them, is similar.
Exactly. Like, on a globe.
Okay.
Distances are kind of proportional, right?
Yeah.
So that's what we want in this embedding space. We want these relationships to be, like,
Yeah.
well-defined, like the globe.
Consistent.
Consistent, yeah.
So where do things fall apart?
Well, the problem is that a lot of current language models, they're like maps that are accurate locally, but they get distorted as you zoom out.
Ah, okay.
So they might understand relationships between concepts that are close together in their representation.
Mm-hmm.
But as you move further apart, those connections get less reliable.
So it's almost like the AI is a little bit nearsighted.
Yeah.
It can see the details up close.
Yes,
But
yeah.
further away, things just get really fuzzy and kind of...
Yeah, the analogy breaks down.
Yeah.
Yes.
Okay. So the research that you've been reading, it's basically trying to address this problem.
Exactly.
Trying to make these maps in the AI's brain a little bit, I guess, more accurate over long distances.
Yeah. They're trying to figure out how to make AI models more globally consistent in how they understand relationships between words.
Got it. And you mentioned analogies being super important here.
Yeah.
Why is that?
Well, because if you think about it, an analogy like king is to man as queen is to woman, that really tells you a lot about how those concepts are related to each other.
Yeah.
And, there's a lot of information packed into that.
It's not just like the words king and man are similar. It's like
Right.
there's a pattern between them.
Exactly. It's the pattern of the relationship that's key.
Yeah.
And the hope is that if we can get AI to understand those patterns across different languages, then maybe it'll have a much better understanding of language in general.
Makes sense to me.
Yeah.
So where do we go from here?
Well, that's where this new data set called WiQueen comes in.
WiQueen.
Yeah, it's a huge multilingual data set, and it draws on this incredible resource called Wikidata, which is this huge collection of structured knowledge.
Okay.
And what they're doing is they're using WiQueen to train these models to, essentially straighten out those maps in the AI's brain.
Cool. So let's start with this whole idea of the analogy problem that AI models are facing.
Sure.
You mentioned that the models sometimes struggle when words or concepts are far apart in this,
Yeah.
Meaning map.
Yeah.
So can you give me like a really specific example of what that looks like and why it's a problem?
Yeah. So like the classic example you always hear, king is to man as queen is to woman, right? A
Mhm.
lot of models can get that one right because those concepts are kind of close together in their representation.
Yeah.
But, as you move to relationships that are more, I don't know, abstract or less common, the model starts to struggle. Like, I don't know if you've ever heard of this, but the BATS data set.
No.
So it's this data set that was specifically designed to evaluate analogy performance in these models.
Okay.
And it has all sorts of different types of analogies, some of them pretty obscure, I guess. And what researchers found is that even the best models really struggled with a lot of these more distant analogies.
Right. And this actually reminds me of a whole bunch of controversies around how we even test how good these word embeddings are at capturing meaning.
Oh, yeah.
Like there was this paper by Levy and Goldberg a while back, And then later, Gladkova, Drost, and Matsuoka created the BATS dataset, as you said. And they were showing that a lot of these analogical relationships, they just weren't really showing up in a reliable way in even the most advanced embeddings.
Yeah, there was a real worry there that maybe we were overestimating how much these models really understood. Because they could get some simple analogies right.
And people like Linzen and Schluter and others, they also argued that the way we were designing these analogy tests, it might have been, I don't know, accidentally making the models look better than they actually were.
Right, yeah.
Because it could be that the models were just picking up on these superficial patterns in the data.
Yeah, like word co-occurrence.
Yeah.
Words appearing together a lot rather than truly understanding the deeper relationships.
Right, right. So, given all that, why is this new research still so focused on analogies if they're so, I don't know, tricky?
Well, the researchers argue, and I think this is a really important point, they argue that if we can train models to understand analogies consistently across languages, then that should lead to something called more isomorphic embedding spaces.
Isomorphic?
Yeah, it's a bit of a mouthful.
Yeah.
But basically, it means that the way the model represents meaning in different languages will be more structurally similar.
So like the underlying map is the same, even if the labels are different?
Exactly. Like a blueprint.
Yeah.
The blueprint is the same, even if the buildings look different.
Got it. So it's like, even though languages are different on the surface, maybe there's this deeper level where the relationships between concepts are actually quite similar.
Exactly.
And that's what we're trying to get the models to learn.
Yeah. And there's actually some evidence to support this idea.
Oh, really?
Yeah. So researchers like Peng and his team, they've argued that there should be this connection between analogical reasoning and isomorphism.
Okay.
And there's also this really interesting finding that when you train word vectors for different languages completely independently,
Sure.
they often end up being surprisingly similar.
Oh, wow.
Like nearly isomorphic, even though they were trained separately.
That's so cool.
It's really cool. And researchers like Kano, Hartman, Kemen Chediva, and Sigard, they've all observed this.
Okay.
So it seems like there's something fundamental to that language that makes this isomorphism possible. And analogies might be the key to unlocking it.
Makes sense. So let's dive into this WiQueen data set.
Sure.
It sounds like it's trying to address some of those limitations we talked about with the older data sets.
Exactly. A lot of the previous analogy data sets, they were pretty small, and they mostly focused on English.
Right.
But WiQueen is huge, and it's multilingual.
Okay.
So it has around 78,000 analogies across 11 languages.
Wow, 11 languages. That's a big step up.
Yeah.
So Danish, Dutch, English, Finnish, French, German, Italian, Polish, Portuguese, Spanish, and Swedish.
Yeah, that's right.
How did they choose those particular languages, though?
Well, practicality played a big role.
Okay.
Those languages are already indexed in this system called SLM.
SLM.
Yeah.
Okay.
And that made it much easier for them to query Wikidata.
Oh, I see. So they were just being practical.
Yeah, and efficient.
They were leveraging what was already available.
Exactly.
Now, how did they actually go about getting these analogies from Wikidata?
So it's a pretty cool process.
Okay.
So first, they identified entities that are represented in all 11 languages in Wikidata.
Okay.
So things like London or Germany,
Uh-huh.
And then for each of those entities, they looked for properties in Wikidata that link them together.
Properties.
Yeah, like, in Wikidata, you have entities and properties.
Okay.
So, for example, the property capital of links the entity London to the entity England.
Got it.
And they also kept track of what type of entity each entity is.
Okay.
So, like, London is a city, England is a country.
Uh-huh.
Then they grouped together pairs of entities that shared the same types and were linked by the same property.
Okay, so London and England would be grouped with, say, Berlin and Germany.
Exactly.
Because they're both city-country pairs.
Yeah, and they're both linked by the capital of property.
Got it.
And then to create the analogies, they took two pairs from the same group.
Okay, so you might get, like, London is to England as Berlin is to Germany.
Exactly. And the really cool thing is that this process, it automatically gives you these cross-lingual analogies.
Oh, I see. Because you're using the same properties and entity types?
Exactly. So you can directly compare the analogies across all 11 languages.
Very clever. You mentioned there are two versions of this WiQueen dataset.
Yeah, so there's the full set, which is all 78,000 analogies or so. And then there's a subset of about 9,000 analogies.
Okay.
And in this subset, They made sure that all four components of each analogy were highly predictable from each other.
Predictable. What does that mean?
So it means that, the relationships in those analogies are really clear,
Okay.
and each entity plays a very specific role.
Uh-huh.
There's no ambiguity about what's going on.
Got it.
So this subset is kind of like a cleaner version of the data
Okay.
for more focused evaluation.
And you mentioned this term analogy distance earlier.
Yeah.
What is that? How does it factor into all of this?
So that's how they measured global consistency. They used this thing called BigGraph, which gives you numerical representations for the entities in Wikidata.
Uh-huh.
And they basically calculated the distance between the entities within an analogy based on those representations.
Okay, so the farther apart the concepts are in this big graph knowledge network, the greater the analogy distance.
Exactly.
Ugh.
And the idea is that a model that's not globally consistent, it's going to have more trouble with analogies where that distance is larger.
I see. So, like, if I'm understanding this correctly,
Yeah.
if the AI sees an analogy where the concepts are very distantly related in its, like, knowledge base,
Yes.
but it still gets it right, that's a good sign that it's learned some global consistency.
Exactly, yeah. That's the idea.
Okay,
Yeah.
makes sense. So now that we have this WiQueen data set, how do we actually use it?
Yeah.
How do we train these AI models to, understand analogies and hopefully improve their global consistency?
So the basic idea is that you want to train the model to encode these analogies consistently.
Mm-hmm.
You want the model's internal representation of the analogy to match, what we humans understand as the correct analogy.
Uh-huh.
And to do that, they use what's called a loss function,
Okay.
which basically encourages the model to make the vectors, the mathematical representation of the analogy,
Yeah.
as close as possible to the vector of the correct target word.
So you're almost like mathematically nudging the AI in the right direction.
Yeah, you're basically telling the model, hey, this is how you should be thinking about these relationships.
Got it.
And they developed different approaches for different types of language models.
Okay.
So for like static word embeddings, like fast text,
Uh-huh.
which are kind of simpler models,
Yeah.
they had to do some extra work because a lot of the entities in the analogies are multi-word expressions.
Right. Like New York City.
Exactly.
That's not just one word in the model's vocabulary.
Right. So they first combined the individual word embeddings to get a single vector for the whole entity. And then they used a technique called the attract-repel algorithm, which encourages the model to bring the vectors of analogous pairs closer together
Oh.
and to push away the vectors of non-analogous pairs.
So you're basically saying these things are similar.
Yeah.
These things are different.
Exactly.
Okay.
And they also included this thing called a regularization term, which helps to make sure that the model doesn't forget the original semantic information it learned before.
Right, because you don't want to completely overwrite everything the model already knows.
Exactly. You want to build on that knowledge.
Okay.
And because these methods only really update the vectors for the words in the WiQueen dataset, they use something called post-specialization mapping to extend that knowledge to other words that weren't in the training data.
Oh, that's interesting. So it's like taking what they learned from the specific analogies
Yeah,
and generalizing it to the rest of the vocabulary.
exactly.
Okay. What about the more advanced models?
So for the pre-trained language models, like mBERT, they use a really clever setup called the Siamese network architecture.
Siamese network. Okay.
Yeah.
I'm intrigued.
So imagine like 4 copies of mBERT.
Okay.
Each copy takes one of the 4 words from the analogy as input.
Okay.
And then they combine the output embeddings from each copy to get a single vector for each entity.
Uh-huh.
And they use a loss function, just like with the static embeddings, to encourage the model to make the vectors of the analogous pairs similar,
Okay.
and the vectors of the non-analogous pairs dissimilar.
Got it.
And for the loss function, they actually experimented with 2 different types, mean squared error or MSE loss,
Uh-huh.
which is pretty standard,
Okay.
and then also contrastive loss, which not only tries to pull the corrupt entities closer,
Yeah.
but also actively pushes away the incorrect entities.
Oh, interesting. So it's like saying not only are these things similar,
Yeah,
but these other things are definitely not similar.
exactly, yeah. And within each training batch, they actually targeted what's called the hardest negative example.
Hardest negative.
Yeah, so like the incorrect entity that was closest to the analogy vector.
Ah, so they're really trying to make the model learn the fine distinctions.
Exactly. Make the learning as efficient as possible.
Okay, and did they have to do that post-specialization step with mBERT like they did with fast text?
Actually, no. They found that it wasn't necessary because with mBERT,
Yeah.
the fine-tuning process updates all the parameters of the model.
Oh, I see. So it's already learning to generalize the analogical knowledge to the whole vocabulary.
Exactly, yeah. And they actually trained mBERT on analogies from all 11 languages simultaneously.
Oh, right, because it's a multilingual model.
Exactly.
Cool.
Yeah.
Now, I also noticed in the paper that they experimented with adding additional information to the analogies,
Oh, yeah.
like alternative names for the entities and descriptions from Wikidata.
Yeah, they called this augmented dataset WiQueen plus N.
WiQueen plus M.
Yeah.
Okay.
So for each entity, they appended its aliases, like alternative names,
Mhm.
and a short description from Wikidata, separating them with a special SEPI token.
Okay.
So like instead of just Paris, it might be Paris, SEP City of Lights, SEP Capital of France, or something like that.
So they were giving the model more context to work with.
Exactly.
Okay.
But to prevent the model from just, cheating and finding the answer in the context,
Uh-huh.
they did some clever masking.
Oh, okay.
So they would hide any occurrences of the target word
Yeah.
within the descriptions or aliases of the other words in the analogy.
I see. So the AI couldn't just like pattern match. It had to actually understand the relationships.
Exactly, yeah. And as you can imagine, WiQueen plus Sherry, it led to a bigger vocabulary and longer input sequences.
Right, because you're adding all this extra text.
Yeah. But they highlighted that the data set is still really diverse
Okay.
in terms of the types of analogies and the entities that are represented.
Cool. So after all this work, all this effort in creating this data set and coming up with these training methods, how did they actually measure if it made a difference?
So they did two main types of evaluation, intrinsic and extrinsic.
Okay.
For the intrinsic evaluation, they just measured how well the model could perform on the WiQueen analogy task itself.
Okay, so like directly testing its ability to solve analogies?
Exactly, yeah. And they used a metric called P at 1, which basically measures how often the model gets the answer right on the first try.
Okay.
And they also tracked that global consistency metric that we talked about earlier.
Right, the correlation between performance and analogy distance.
Exactly. And for the extrinsic evaluation, they tested how well the model performed on downstream tasks.
Okay, so like tasks that actually require the model to use its language understanding abilities in a more real-world setting.
Exactly.
Okay, got it. So starting with the intrinsic evaluation, did they actually see improvements after training on analogies?
Yes, definitely. So for both fast text and mBERT, the analogy training led to improvements in P at 1 on the WiQueen dataset. But what was really interesting was that mBERT showed a much bigger improvement in the global consistency metric after the training.
So it wasn't just getting better at solving the specific analogies in the data set.
Right.
It was actually improving its overall understanding of those relationships across a wider range of concepts.
Exactly, yeah. And they actually gave some examples of new types of analogies that mBERT was able to solve after the training.
Oh, really? Like what?
So things like spatial relationships, like, Tripoli is to Tripolitania as Thessaloniki is to Macedonia.
Okay.
Or temporal relationships, like about the order of albums in a band's discography.
Oh, interesting.
And even relationships about, like, who occupies what stadium in different sports.
Cool.
They did note, though, that another model, XLMR, didn't show as consistent improvements.
Oh, okay.
So it seems like the effectiveness of this analogy training, it might depend on the specific architecture of the model.
That makes sense.
Yeah.
Now, for the extrinsic evaluation, you mentioned they looked at bilingual dictionary induction and sentence retrieval.
That's right.
Let's start with BDI. What is that exactly?
So it's basically the task of automatically creating a dictionary between two languages.
Okay.
And in this case, they were evaluating how well the models could find translations of words by looking for the nearest neighbors in the embedding spaces of the two languages.
Okay, so like if the word cat in English is close to the word gato in Spanish in this embedding space,
Yeah.
then the model would say those are probably translations of each other.
Exactly. Yeah.
Okay.
And what they found was that analogy training led to a big improvement in the precision of finding the correct translations.
Oh, wow. So training on these analogies in one language was actually helping the model understand relationships between words in a completely different language.
Exactly. Yeah.
That's really cool.
That's really cool. Yeah.
Did they have to use that WiQueen plus data set with all the extra information, or did the regular WiQueen work better?
Actually, they found that training on the regular WiQueen dataset without the aliases and descriptions worked best for this task.
Oh, interesting. What do you think that is?
Well, maybe it's because, when you're actually doing BDI, you don't have access to all that extra contextual information.
Right, you're just working with the words themselves.
Exactly, yeah.
Yeah.
And they also use some more sophisticated mathematical measures to quantify how similar the embedding spaces were becoming.
Like what?
So things like the average Gromov-Hausdorff distance and isospectrality.
Okay, I'm not familiar with those.
Don't worry about the specifics, but basically they measure how structurally similar two spaces are.
Okay.
And they found that these measures show that the embedding spaces were becoming more similar after the analogy training.
Cool. So it's more evidence that this training is actually making the models more isomorphic.
Exactly, yeah. It's not just about getting better at solving the specific analogies.
Yeah.
It's about changing the way the model represents meaning in general.
Okay, and what about sentence retrieval?
So for that task, they use datasets called Tatoba and BUCC 2018,
Yeah.
which basically involve finding sentences in one language that are translations of sentences in another language.
Okay.
And they found that analogy training led to improvements in accuracy on the Tatuba dataset and in a metric called F1 score on the BUCC 2018 dataset.
Okay, and these improvements were consistent across all 11 languages.
Pretty much, yeah, for most of the languages they tested.
And what's really cool is that they saw improvements even for languages that weren't directly part of the WiQueen training data.
Exactly. So it seems like improving the global consistency of the model, it has these ripple effects
Yeah.
that extend beyond the languages and analogies that were explicitly used in the training.
So just to wrap things up here, it seems like this research has shown that these pre-trained multilingual models like mBERT, they're really powerful,
Yeah.
but they have this limitation,
Yeah.
this global inconsistency problem where they don't always understand the relationships between concepts in a consistent way across their entire representation space.
Yeah, and that's a big problem if we want to build AI that can truly understand language
Right.
across all these different languages.
But this research shows that training on analogies, especially using this WiQueen dataset and that Siamese network architecture,
Yeah.
it can significantly address this issue.
Yeah, it leads to better global consistency and more isomorphic embedding spaces.
And that, in turn, leads to better performance on these real-world cross-lingual tasks,
Exactly.
which ultimately helps us bridge that digital divide that we talked about at the beginning.
Yeah, it's all about making AI more accessible and more beneficial.
Yeah, it's really amazing to see how this focus on the relationships between concepts, these analogies,
Yeah,
can lead to such profound improvements in language understanding.
it's exciting.
It makes you wonder,
Yeah.
what other kinds of relational knowledge are out there that we could use to build even more robust and universally capable AI systems?
That's a great question.
Yeah, definitely something to think about.